I'm now going to try the transducer with the light. You pretty well see the light. I'll have that on another camera. It's on the back. You can't see it. I can turn it around, I suppose. Turn it around and you'll see it on the other camera. I can't guarantee it will work. No idea. It's battery. I'll turn this around. It's all set, so it should work. I haven't plugged the plugs in yet. Very nice. And this plug. There's two plugs. This gun goes in here. This one goes in here. Simple. Just make it around there. So that's the two plugs. It's all set up now. There's no more to do. And I haven't got the regulator in. There's the spark down here. And so you'll be able to see the light from there. And that's that thing there is the inverter. There's the battery there. And this is the switch now. You switch it on. And this is the level control to when it changes over. And that's all I can do. And I run it until the battery runs down. And if it doesn't work, it doesn't work. That's all. I've got the high voltage line connected, and the other one. I'm going to turn on the neutral detector now. That's not on. There's the upper one's a neutral detector. Okay, there's that very few neutral frequencies. So there you go. No big deal. I'll turn it over to the camera now. You can see it, that's there, that's the light, it's just there. There's a switch to turn on. This is the level control. So now turn it on and see what happens. That's all I can do is turn it on and see what happens. I can't do anything else. I don't think anything happened. Nothing happened at all. There was a hum to turn off this, probably run the fuse. Let's see sort of current. There's some current here as well. And just nothing happened. Interesting, nothing happened. It didn't even turn off. So I've got a current meter on here. So I can see what the current is. I should have done that first place. But it doesn't surprise it. There we go. How you worse first time. They worse first time. And that current, that current is the current through the switches. That's the current through the switch. Yeah. Just the current through the glass one. I'll see so I'll turn again so no current at all. No current at all. What's that one? No current at all. Lights on. Lights on. It started, something happened when I first did it. It stopped. Something's wrong. So nothing happened, which doesn't surprise me. Always like the first time I tried it, always the same. So there's probably no voltage going on there. This must be what's going on with the fixtures. So I've got various fixtures to test here. The next thing to do is to test where the rush is going through this out of the way. I'm not surprised at this. Always when you test something, always no happens. First time it's right, no happens. And where's she finds a fault? Usually, that's right. So this should be 12 volts here. read the, I see. I'm trying to try this. Actually, which is the it's actually red now. It's here. So it's gone wrong. And that should be 250 watts on the input. There. Let's see input. There, the inputs. 250 watts goes. Run the transformer. It could have done the transformer. That's what's happened. Run the transformer. Ah, wind up. There's no current going in there. Okay, see. There's no current on it, so that wouldn't have done the transformer because that's coming from here. The load of the fuses runs. That's what's all. So turn that off. Load of fuses runs. What fuse was it in there? It's actually box. So the fuse is in there. Which is probably the wrong one. It's a blue straight away. So it takes, I don't know what current it takes. It's not very much actually. Can't even get this security screw off there. So we'll find that security screw takes it off. And it's quite cold in here, so I've got this hat on. So something, I think I blew a fuse in this mains plug, protecting the inverter. So that's protected the inverter. It was actually it should be very much. Yeah, sure. It's 3 amps. It's 3 amps. It's quite a small fuse. So it's actually DC 12 watts. 20 amps inputs. 150 watts. 150 watts at it's not very much, is it? 250 watts. It's not very much. 1 amp with 250 watts. That's actually not one. Let's see what happens. Let's see what the through log land. Let's see what's that now yes, that is like that. And so see the fuse runs. That's good. I've lost the fuse now. I put things down, I forget where I put them. Run the fuse. Run the 3 amp fuse. That isn't. Fuse is okay. So it must be damaged to the inverter. Let's put this in that top one. And we'll see what the fuse like. See these circuits. You know how to measure the resistance of that cord to see the cord grams. Let's see what that is. That's 0. Zero box. Interesting. So that seems to blow out the inverter. So maybe it did work. Real problems, real problems. I could plug in the ranges first, plug it up. Oh, what's happening? This is no good either. I wonder if the battery is flat. Strange. So I'll blow that up. It was, shouldn't it? It came on for a second, but then it stopped. So what happened with it now? Cherry original gas. So I'm now going to check the resistance of those windings to see if I've got other windings. It's less likely. It's actually correct. The blood windings. It is. That's okay. It's not blood runs. Actually. It's actually giving a radius. I think the another one is runs. Just be with you some sort of it. It's oscillated, so that means there's not a shadow. Okay. So just give them a read. There is something going on. I don't understand it at all. So something's gone wrong. So we brought up the inverter. If you have a substantial inverter on it takes 20 amps for that. So well, brought a fuse of that. There's a light come on there. Now that means it's live. So why doesn't it have to get voltage? Maybe a cut out of it, which is will come back on again. Traction plugs are going properly. Let's see what's this. It's 240 volts there, so it is working. So back in business. Okay. That must have reset. Let's just set this off. And then plug it in. So again, put the fuse back. Really ought to be with the amps really. Sorry, that was rounds. actually there was a single start with that it stopped. So it's only cut out. We're going to put a resistor in, protect the reduce it to make sure it is right current. That's right, yes. I've got the resistors. So the current is going to be, basically, the current in through there. It's going to be 10 amps. So there's 12 volts there. So that's 1 amp. That's actually 1 amp. It is right. So it is right. It should be 10 amps. And 10 amps is the limit of the thing. It's on now. Try again. Let's just measure the voltage on the cylinders. It's actually, it is, the voltage is there. Voltage is on the voltage there is on the system. If I turn it over, it should actually go. It starts immediately. That's not good. Starts immediately. It actually stops immediately. That's interesting. So this must cut out somewhat. So if I limit the current, that will improve things. It's best like this. Let's take that off. If I limit the current, where's the current? We're going to put the current in there. You see this one? The current switch will go this. So currently it is a resistor, and I think we've got a small resistor, a big current. It takes 10 amps through one ohm, which is 10 watts. It's 10 watts, isn't it? I need a 1 ohm resistor. We've got 1 ohm resistor here. Go to a 1 ohm resistor. We'll add that, but it's actually somewhat 10 ohms or not. These use everything else. Okay. I have to measure these resistors. Quite difficult to measure resistors. This one. So that's 10 watts, 10 ohms. So this is 1 ohm. I want to buy a resistor of 1 ohm to make the current 10 watts. Five ohms. 5 ohms. 5 ohms. That's not too bad. That might do. We'll go through that. I've got the contact resistance. 5 ohms, which actually reduces the current quite a bit. So I'm going to take that plug off and place a 5 ohm resistor. How am I going to do? We're going to put it. And we're going to put the 5 ohm resistor. This actually must reset. It must be some clip, I think. It resets and unclip that. I'm going to put it that. Actually, that's too much. 5 ohm resistor. We all have pretty out of box with resistors in to control the current. Look, this one is. There's no markings on this one. Actually, that's 3 ohms. That's better. It's probably about 2 ohms. That's what ohms. So that one's a bit off. So what I'm going to do is to it's plug out. Where will I put it? Where can I put it? Which is convenient on this circuit. Convenient to limit the current to 10 amps, which won't over the transformer. Which actually it's not over the transformer. It's over the cutout. So I wonder what the cutout is 100. It's actually was it the is actually 150 watts. Actually, it's 150 watts. Let's see what that is. That's 150. It's actually half an hour. It's not very much. Which is right. Which is right. So if I go in the input, that's 10 watts, 10 amps, 12 amps. It's 120 watts. That's about the same. So about right. Something's happening. Something's happening. I can throw something. Or something burning. I think I'm on the screen. I think I'm on the screen. So I think I'm on the screen. It's difficult to do stuff at the scroll. I can throw something. Throw them is important because these systems can't do that. And there's no current flow. No current flow anywhere. The straw, which probably straws come from straw. I'm going to cut this cable and we'll put a resistor in. It has to be a different resistor. Cut this cable here. Put a resistor in. That's a good idea. So I'll cut the cable. Put a resistor in. Put the solder in there. That divides the cable, and I've got this 3.0, it's better at 7, maybe less than that. This is there, but it's a 10 watts, it's a 10 watts, it's 10 watts, yes. So let's get the cable. You see, the doctors make it as first time fast, which means you don't reason so much. And they think they're doing wonderful work, but they're really just racking up people's minds. It's not really good idea. They think they're healing people's minds. They have tests and things. But I resent being told that their treatment makes me better, because it doesn't. It makes it worse. And I remember my mother's life for the same reason. They thought because she didn't do very much, she was very wrong. In fact, she was quite intelligent, really, and she was not communicating. That's all. She's not saying a thing. And so the doctors do this to go to prison. And they're just criminals, as far as I'm concerned. And insanely, when we go to work at 71 staff, I've got some mad idea that the people's work will be improved if they go to work at 71. That's not true. I mean, the idea that investments go down, but if they steal money, it's obviously they stole money a lot more, and eventually they ruin money. And especially, I think that's all angry, actually. Who got the idea? Somebody that's this mad idea. This campaign getting people into work into the money. He's already done his lives. He's good in other words. He's going to suing people for all sorts of reasons. Not just that. He's still mad, but he's making money by British prosecution and British criminals. These criminals they damage brains and make you stupid. They made me. I noticed my speech patterns are different now, and I'm not happy. My speech is not as it was, and that means I'll be brain damaged. And that's a shame for it. They thoroughly think they're doing wonderful work, but actually ruin lives. The schizophrenia is actually intelligence like us, and they don't like intelligent people. That's what it is, making people stupid. And they often say they're stupid. Well, of course they do. Make them stupid. That's why. It's wrong. And they say making people go to maximum reward and stuff. Eat it at source. So not intelligent. Not intelligent. Basically, they're slaves. It's a slaver. They make monkey starts to for the bananas, so they make peel parts for them as well. I put the 1 amp in. It's probably 1 amp actually, but it's there's a bad contact. It read as 3 amps. So actually that should limit the current to 10 amps. So it shouldn't blow the rise up now. And that's now should give a result. There's no signal on there, so you press the button. And, that's cool. That's cool. So we'll try this again. That was gone up. That's now reading something. That's now got some current going into it. It's actually 4.8 amps going in. That's reasonable. So there's nothing happening, no signals, no nothing. And so that before I did get something, but it was probably a misreading. And unfortunately, I make mistakes to somebody else. And let's see. There's no signals anywhere. The sine waves aren't working. Nothing's working. Nothing's working at all. The sine waves on the output aren't working. There might be something there if I turn the gain down enough. But nothing's happening at all. Which is not surprising, isn't it? That's 1,000 times down, so let's see if we can, that's 100 watts. There's nothing on it at all. Nothing. Utterly nothing. That's interesting. There's no output from the portion. This at all. See if it's actually running. See if it starts up. There's no signal on there. Nothing at all. My circuit using a transistor is better actually. That seems to be. There's nothing on there at all. So there's no output. Maybe I've blown the fuse. Maybe the wires run. All sorts of things could happen. And there's no way of testing it because it could have been damaged by something. But you can't tell, can't measure it. You can't repair it. Once it's blown, it's blown. And so it's blown. So it could be the cable, the wire, and the winding is blown. The only way to do that is to measure the resistance, and that can become interesting. So all this work, and if the winding is blown, that's the end of the story. Because I can't repair it. There's no road for repairing it at all at the end, and so it's blown. And that's it. So there's actually current going in and nothing coming out. There's nothing coming out of the output. I'll go voltmeter because that's just what there's current flowing in the input, which is 4.8 amps, which seems to be coping quite well. That's reasonable. Let's see what the output is. There's no signal on this one. No signals anyway. So it's obviously blind. This may have blind this from the coil. So I'll start all over again. Why a new coil? That's very, very bad. Here's one end. Where's their end? That's one end. And there's their end. It's actually, oh, there's 103 volts on it. So there is voltage there. 103 volts. 102 volts there. That's right. So it might suddenly start up. There's 102 volts there. So there is something coming out. It actually is working. So this probe must be 40. What's happened to it? I don't know. But it's very wrong with the oscilloscope. All sorts of things can happen. This oscilloscope, so that's possible. That seems no good. I'll take this off. Just let it break off. So good. That's 40. It may be just a 40 connection. There's no signals on there at all. So that's tuned for a while. There's no signals coming out. Let's try the other circuit to see what the output voltage is on the other circuit. That's no good. There's no deflection on the S reset, so that's dead loss. So there's 4 amps, and let's see what the 4 amps. It's reasonable. It's got a reasonable current. Let's have it up. I tried it out last time. Let's just do this. And this change stress valve as we got. It's gone down out of 395. Let's see what the voltage here. There it is. It's actually actually 0. .6 volts coming out. That's 0.6 volts. There's 0.6 volts coming out there. That's no good. What's the voltage going in? Actually 11 volts. 11 volts going in. That's outside the resistance. On the other side, it's 3 volts on the winding. It's actually got a lot of power going in. So I need to put a meter on this thing here. I've got another meter. It's getting warm now. That's this resistor here. Getting warm. Actually 4 amps. 4 amps. It's getting quite warm now because that's that resistor there. That's not getting on. Nothing's happening. No signals at all. And there's nothing coming out of the S meteor at all. There's no signal there. No signal there. So it's a very small output voltage now. And that's DDoS. Really DDoS. So it's obviously connecting that output to the thing is actually no good. But there is a signal going in, and it's insufficient to run it. Insufficient to run it. But it's probably not a very good connection between the input code and what's going on. There's all sorts of things wrong with it. And I'm not surprised it doesn't work. Because it did work to start off with, and that's because it's running a huge current, It's running 10 amps, or whatever it is. 10 amps is actually not working. So that's not surprising. But that's because there's things wrong with it. Not because there's a mistake. And it's actually this output here is very low. It's very low. That's what it is. There's all sorts of things wrong. And so you can't really notice it. There's 4 amps going in. And it should be 10 amps, so it's less than it should be. And I've done some mistakes. There's some mistakes in my design. There's not enough turns on the primary. There's actually 0.6, 0.5 watts there. 0.5 watts. There's actually the current voltage going in, there's a sinus voltage going out there, which is 0.5 volts. So that's right. So I needed more. It's actually quite interesting. It's actually needed more power going. Interesting. So this is now 3 amps. I've gone down to 3 amps. So the power's going down. So that didn't work. I'm not surprising, but it didn't work. And I was disappointed, but saw what the voltage across says, and it actually needs more current. It needs. I said 10 amps, so that resistor has to be lower. It's a small resistance. That's resistance. It's actually 200 volts. It's 200 volts going across there. 100 volts. But this is designed for that voltage to be 7,000 volts. So it's not enough. I think we can see about doing a different doing the sudden stroke. Because I had it before on a transformer, which is a mains transformer, and this didn't cope with the current, but it should have been 10 amps on the output. It's a lot of drop because that resistance now gone down to 2 volts, so I'll turn it off. That's a failure. There's no result. No result because it wasn't. There's no result because that high voltage probe was not showing any signals. I'll put it back. That should be 40. That's not plugged in. That's the voltage. The black has come up. No signal. Get no signal. It's only a 40 probe. 40 probe on there. There's a real voltage there. It's a 40 probe. Let's get another probe. Another probe. 40 probe. It's worth measuring that voltage. So this is probably 40. All sorts of things go right. So that's probe. Where's the other probe? Another probe on. There it is. Probe 7. I'm not surprised, and other people will get a better result than me. Does that better equipment? Well, it works outside. It did work. It did work, so it should work. And it needs something more than it's only 200 watts we drove to cost it now. So of course, there's no sound waves from the receiver from the neutron detector at all. I think that's what neutron detector it's already set on 20 milliwatts. That's 100 milliwatts. There's actually no signal. It's actually dropped up. It's dropped up. That's from my assumption. There's no signal at all. And it's not right. There's every signal on this scope. So that's scope. That's no signal. As long as this oscilloscope I'm wrong. As soon as I put too much voltage through it, that's what it was. It may have started up. No, I might have started back up. So that's no good. This oscilloscope is no good. I'll disconnect that. Just have the neutron detector. This smoke there's maybe a surge of voltage which I couldn't see. But there's no output. That's it. This light hasn't come off. No signal. It's a shame, but that was a good try. There's no signal here. The S meter is rising and falling. It is there, something there. I'm just looking at it. I think there's several things I can do. I can have a smaller resistor to bring the current up to 10 amps, because that's the design resistor. The voltage may have risen above 200 volts. It was 200 volts, so it may have risen above that, but it couldn't be seen because the oscilloscope didn't detect it. So I had to put a voltmeter on it, high voltage voltmeter, and that's the answer. So I can't measure it with an oscilloscope. And the oscilloscope is no good, especially this PC oscilloscope. And so I'll have to come off. Fortunately, that's it. This is the probe. That's the other probe there. So I'll put the other probe on. This is very oscilloscope we have blind. There's times 10 on there somewhere. Nothing at all. There's anything happening on that oscilloscope at all. And it works. It works. So it's going up. You may be able to focus on it. Right up. so good. I'll have to remove this one. That's a shirt, probably it's not working. Not working. That's not this. Is this shirt plugged in? Is this shirt plugged in? That's the point. It's possible the oscilloscope isn't plugged in. Is this plugged in? The oscilloscope wasn't plugged in. Really helpful. Really helpful. So it does. That's right, little root. That's a little root, that is. As you said, let's just plug it in.